Good morning, my SS2 physics students. As you can see on the board, we are continuing with the refraction on triangular glass prism. So we're going to finish it now. Remember the other time we were able to discuss the following: angle of incidence, incident ray, angle of refraction, refracted ray, angle of emergence, emergent ray, and angle of deviation. Now, as angle of incidence increases, the angle of incidence increases, incidence I increases, the angle of deviation decreases. Angle of deviation decreases to a particular value. Beyond that, the angle of deviation D increases with the angle of incidence. The angle of incidence. This occurs when the light passes symmetrically in glass in the prism. That is I equal to E. So when angle of incidence is equal to angle of emergence, angle of incidence is equal to angle of emergence, the light is said to have passed symmetrically in the prism. And at that time, angle of deviation increases with angle of incidence. So the last value, the minimum value of D at which this occurs is called angle of minimum deviation in bracket DM. So we are going to do this in practical when the lockdown is lifted. It's a good practical question or exercise, both in WAEC, NECO, and in ordinary practice in the lab. You have to use it to discover the angle of minimum deviation by a particular prism. And this, why do we need this? This has a very good value in finding the refractive the refractive index of the glass prism. Remember, I told you for rectangular glass prism, talk about sine I over sine R, or V1, that is the first medium, over V2, velocity of the first medium, or velocity of the second medium, or real depth over apparent depth, or mu2 over mu1. Remember that when you go to mu, that is the refractive index of 2 media, is the refractive index of second medium to that of the first medium. So how do you use this now? Mu for triangular prism is equal to sine half bracket A plus dm all over sine half bracket A, or I can say mu is equal to sine bracket A plus dm all over 2 all over sine A over 2. I hope you know what A stands for here. You know that I gave you what A stands for. A is the refractive angle of the glass prism. And remember you are using equilateral glass block. Here is A, and it's always used. Because when you say equilateral, it means that all sides are equal. And if all sides are equal, all angles are equal. And if all angles are equal, each angle is 60 degrees, because the angle of a triangle is 1/8 divided by 3, that will give you 60. So from here now, you can find mu. So assuming that dm is 37 degrees. dm is 37 degrees. If you take it, that value, or 38, let's say 38. Let us see what mu will be. Mu will be sine 60 plus 38 bracket all over 2 all over sine 60 over 2 over 2. You take it, we are going to calculate now. Whenever I pick my calculator, you pick your own along with me. Now 60 plus 38 will give you 98, divided by 2 will give you 49. So that becomes sine 49 over sine 30. What is sine 49? Go back to the calculator or your phone. Sine 49 is 0.7547. 0.7547 over 0.5. Know that sine 30 is 0.5 without being told. So when you divide, if you divide 47,547 divided by 0.5, you arrive at 1.5094. 094. Under approximation, 1.5. Remember that the refractive index of glass is 1.5. So that's how to find it. That's the importance of dm, the angle of minimum deviation. With this, I would say I have finished with calculation of refractive index. I will now go to prism. Continue with the prism. What other uses of glass prism? Glass prism, that will take me to dispersion of light. Dispersion of light. What is dispersion? What is dispersion of light? You know that white light has 7 colors. 7 colors, and when these colors are separated, the idea is known as dispersion of light. Dispersion of light. So if you follow my explanation, dispersion of light means separation of white light into its 7 component colors. Into its 7 component colors. So that is dispersion of light. You see, I told you that refraction occurs because the white light travels with different speed when it moves from one medium to another. Then the same thing, dispersion occurs because different colors of white light move with different speed in the prism. So when white light enters the prism, the colors move with different speed. So when they move with different speed, you will see the colors one by one. Just like you are running long distance races. Just like 3,000, 5,000, 7,000. You see, after the first round of the fair, second round, third round, you see people coming. You see the gap will be separated, unlike 100 meters race, where it's very, very close. See people, first will be clear, second will be clear. So people will not come in at different time. So here, because they move with different speed, the colors are being seen differently. So that's what we call dispersion of white light. Then this can occur in a prism. This can occur in a prism. Can occur in a prism. Prism can be used to separate it. So let us see the how prism can be used to do that. When you have a dark prism like this, a prism like this, then this is white light coming here. So here is red, R stands for red, O stands for orange, Y stands for yellow, G stands for green, B stands for blue, I stands for indigo, and B stands for violet. 1, 2, 3, 4, 5, 6, 7. 7 colors of white light. So when you have it like this, you can get it from R to V. R to V. Look at the colors of white light. Then, this separation, some colors do overlap. You cannot see the colors clearly different. Sometimes they overlap. So this is called impure spectrum. Impure. What do you call impure spectrum? Before you talk impure, let us know what is by spectrum. So when these colors of white light is being separated, and you see it on the screen, screen means white background. If you see it on the screen, that appearance on the screen is what we call spectrum. You know, when you want to see cinema or in a crusade, they want to shoot all those things. They will have a white background. That white background is called screen. So when these colors appear on the screen, it's called spectrum. Because of overlapping of one color with the other, it's called impure spectrum. We have pure spectrum. Let us know the impure spectrum. The impure spectrum is a situation where some colors overlap in the screen. Where some colors overlap in the screen, known as impure spectrum. Then, so we use glass prism to do that, but what we are going to take here is impure spectrum. And let me tell you, you can do it at home. Get a biro, go near your window and see if there's any way rays of light can enter your room. Then use the biro to block it and place a white paper behind the biro. You will see, turn the biro, you will see some colors on the white paper. Try it, you will see it. I observed that when I was even in secondary school, primary school, not secondary school. So when the issue was discussed in secondary school, I was able to relate what I observed. I saw it by accident. I don't know what I was doing, but I saw that color. So I started saying, okay, that's what I saw that time when I was in primary school. So go and do it. The ray will not be too much, just a small ray coming through your window. Then blocking with biro, you see it. Then let us go to pure, how to produce pure spectrum. Then you can produce pure spectrum by using the following. And produce pure spectrum by using the following. You know, pure spectrum is a situation whereby the colors are seen distinct on the white background on the screen. Colors appear distinct, they are separated. So you have the following. You have the apparatus like this. I will draw it, then I will name the apparatus. So here we have remember, I'm going to draw this without arrow, score is 0, because what you do is light. The one that arrow, you have drawn rays of light. What you draw is of light, not light, line. So with arrow, you have drawn rays of light. So see what happened here? This is light source. The job of light source to provide the light rays. This is narrow slit. You know, I told you, like a window, it must be a small opening. Narrow slit. The light was first taken to converging lens A. The job is to converge the light. So from there, go to triangular prism, 60 degrees equilateral. So there, the light is being undergo dispersion here. It is 1 here, it is 2 here, 2 here. You can see here, this is 2. Then from here, the converging lens B will do more dispersion. to bring it here, and then the screen, we are going to see the colors. So here you see red, orange, red, orange, yellow, green, blue, ultraviolet. Then from here, you see that red deviated least, while violet deviated most. Remember I told you some time ago that when you are running, maybe vacancy and people are pursuing you and they are running for your dear life. Well, why I use the word vacancy that when they meet you, you know what they happen at the end of you on this earth. So you know the type of running will be applied there. Then, but if you are running and meet a slippery ground, automatically you must change your speed. If you run in that same speed, it may fall. So you must change your speed. So when light enters the prison, the light will change its speed. So when you change its speed, that's because about deviation. It will deviate, as you know, angle of deviation. So red deviated least, while violet deviated what? Most in that order. So that is how to produce pure spectrum of light. Pure spectrum of white light. Then I move on, I go to color of object. Color of object. Color of object. That will take us to primary colors and secondary colors. Before I talk about secondary color and primary color, the color of any object is color that object presented to the eye. Color of object. The color of object is color it presented to the eye. And I told you that white light has 7 colors. So that object appears green when viewed in white light, meaning that it absorbs all colors of white light and reflected green. So it is green because all the colors are all absorbed by that object and then give the eyes green. It appears green. The same applies to red object or any other color object. But when the object absorbs all colors and reflected none, it appears black. It appears black. So I will say that a green object appears green when viewed in white light because it absorbs all colors of white light and reflects green. The same applies to yellow flower or blue cloth. On the other hand, black appears black in the white light because it absorbs all colors of white light and reflects none. White object reflects all colors of white light and absorb none. That's why black and white are a very good matching color. Women will know more about that. No, they normally put matching colors. Men don't talk about matching colors. So when you put white shirt, automatically you must try to get black trousers and all the rest. So there are 2 matching colors. You can use white and wear any other color, same as black. Because look at these 2 colors. White reflects all colors and absorb none, while black absorbs all colors and reflects what? None. Then that will take us to color table. Color table. We have 2, 3 types of colors. We have primary colors, we have secondary colors, and have complementary colors. And if time will not permit me to go into it, but I will use color triangle. Quickly, I'll draw a color triangle for you to meditate over it before next lesson. Color triangle. I'll give you color triangle. That is a very good way you can know all these colors. I will just mention it and then you meditate over it. If you so wish, I use the word if you so wish, because some of you are not serious with your studies. But I wish you are serious with your studies so that all the effort by the school will not be in vain. So here, red, green, blue, primary colors. So they are not produced by any other color. They are just their primary colors. And when you add them together, they will give you white light. Here is white light. Then from here, I have yellow here. I have cyan. And I have magenta here. Now, this yellow, magenta, and cyan are called secondary colors. So these are colors produced by combination of two primary colors. Red plus green will give you yellow. Green plus blue will give you cyan. And red plus blue will give you magenta. Then if you look at it now, you see that, remember this is white light here. So green plus magenta will give you white light. Yellow plus blue will give you white light. And red plus cyan will give you white light. These two colors, one primary and one secondary, that join together to give you white light are called complementary colors. I will stop here. Next lesson, I will say more about that.